Hey there everyone, welcome to Saurav's classes. So this is part 3 of our solution for IIT JAM Maths 2023. So the question in front of you is given that V is the volume of the region as belonging, that is a subset of R cube defined by the following set notations, and the important boundary here to be noted is Z lies between x by 4 and x square plus y square is within the range of 0 to 1, and this is obviously a question of circle. So now in order to find out the volume here, so what we are going to do is find out the area. So in order to find out the area, so we can integrate dx, dy and dz. Okay, now in place of this we can write down the following, that is so this is equivalent to let's say this of this. So integration of dz is z, and we have dx dy. Now z lies between xy to 4, so the range is from here. So now this can be written as 4 minus xy dx dy. Okay, now now one more condition given is the circle of equation, right? That is x square plus y square, that lies between 0 and 1. So from here the radius should be 1. Now if I take x is equals to r sine theta and y is equals to r cos theta and put it here, then we have theta is equals to 0 to 2 pi, r is equals to 0 to 1, because this is the range here. It's given. So here we can put 4 minus, so this is the multiplication, so r square sine theta cos theta, r square sine theta cos theta. And if you know, dx can be written as r d theta, right? Dx dy, this can be written as r d theta. Now d theta dr, sorry, yeah, d theta and dr. Now so this can be written as, so theta is equals to 0 to 2 pi, and we can write down the following. For theta we can write down, so we are going to multiply, that is r cube sine theta cos theta d theta dr. So there is minus here, minus of r cube sine theta cos theta d theta and dr, and here we have, okay, instead of doing in this way, first let us simply multiply and then we will put the integrals, right? So if you multiply, so first let us have our limits and we just multiply, that is we have 4r d theta dr minus r cube sine theta cos theta d theta dr. Now let us put the integration, right? So we can write down 4r dr and d theta, so that is theta is equals to 0 to 2 pi d theta, r 0 to 1 r d theta, sorry, this is 4r dr. So this part is done. Now minus, again theta is equals to 0 to 2 pi r cube sine theta cos theta, r is equals to 0 to 1 dr, right? Now so yes, here we have d theta. Now this d theta here can be written as d sine theta. So here we can solve this as follows. So let us just solve all the part one by one. So this should be here, my mistake, this is r cube d cube. Yes, now let us just find out this. So d theta is basically theta from range 0 to 2 pi, and this is 4r square by 2 from 0 to 1, minus, now here what we can do is cos theta can be written as d sine theta, right? So this can be written as follows, that is theta is equals to 0 to pi sine theta d sine theta. Cos theta d theta can be written as d sine theta, and here we have our r to the power 4 by 4, 0 to 1. Now if we put the values here, so this is 2 pi, 2 pi minus 0, 2 pi. Here we have, so this is 2r square basically, so 2r square will be 2 simply. Now minus, if we take the sine theta d sine theta, so this is just sine theta square by 2 within the limits 0 to 2 pi, and here this is 1, right? So if we write it simply, this is 4 pi minus sine 2 pi, so let me write down here, that is 1 by 2, and in brackets we have sine 2 pi square minus sine 0 square. So this we have to now solve. So if we put the value, sine 2 pi is 0, sine 0 is 0. So this term is actually totally 0, right? And we have only 4 pi. That is, we have 4 pi minus 0 is equals to 4 pi. So we were actually calculating v. So that means v is equals to 4 pi. Now in the question we are given, we have to find out what is v by pi. So that means from here, v by pi is equals to 4. So 4 is our correct answer. Next question. So the next question here is given as follows. Every infinite group has infinitely many subgroups, right? So let us talk about the first statement. So according to the first statement here, we can say that we can represent it as, suppose this is the group that we are representing Z. So there is one subgroup of, that is say Z1 and plus, so that is goes on, but we have, for that also we will have Z. So of course you can see that according to the statement 1, what the information that is given for the infinite group has infinitely many subgroups, we can see that only 2 subgroups here we can form, so that means it is finite. So I can say that the first statement is wrong. And talking about the second, if there are only finitely many non-isomorphic groups, right? So as per the second group here, so let's say this is Z2. Now this is isomorphic, that means if we go on with this, so this will also be not equals to this. That means if we go on like this, we will get this result. So this is definitely not finite but infinite, right? So statement 2 is there are finitely many non-isomorphic groups. So that's not true, because here we have infinite groups. So statement 2 is also correct. So both 1 and 2 are false is the correct answer. So we are given, let f is such that r 3 tends to r, we defined as f of x, y, z, where the function is given as x cube plus y cube plus z cube, and let L is such that this is equivalent to r, let the linear multiplying this. So we have to find out the value of L 1, 2, 3, 4. Now for that, here first we have to write down, say minus of L x y z is equals to x of first derivative, y of first derivative plus z of first derivative. Now this we have to find out at the point 1 comma 1 comma 1, 1 comma 1 comma 1, and again 1 comma 1 comma 1. So first using this fx given, let us find out the derivative. So fx, from here it is 3x square, f of y is equals to 3y square, and f of z is equals to 3z square. Now at 1, right, when the value at x is equals to 1, so this is equals to 3, this is equals to 3, and this is also is equals to 3. So now let us put the values here. So we have minus of L x y z is equals to x into 3 plus y into 3 plus z into 3, right? One more thing here that is to be noted is the sign, that is there is minus sign here. So we have, sorry, so this should be minus, minus, minus. That means minus, minus, and minus. So if we take all the minus 3 as common, then this is equals to minus 3 of x plus y plus z. So minus minus gets cancelled. So L of x, y, z is equals to 3 of x plus y plus z. So what we have to find out is L of 1 to 4. That means L 1 comma 2 comma 4 is equals to 3 into 1 plus 2 plus 4 is equals to 3 into 10 is equals to 30, and that is the answer. Let us solve the next question here. Again, the question given is basically the number of permutation in S4 that have exactly 2 cycles in this cycle decomposition is equal to how much? So here we are talking about 2 cycles of S4. So first of all, this is S4. So 4 can be decomposed like 2 to 2, 1, 1. So here we are only talking about 2 cycles. So this is 3. So this is not what we are going to calculate. We are only going to take the 2 cycle. So this and this. So what is the permutation of this? So obviously there are 2. So 2 to the power 2 of what? 2 factorial, right? So the answer is 4 into 2 is equals to 8. So it is 8. Let us look at the next question here. So the next question here is as follows. So you have to find out the maximum possible order of a cycle in S8, right? So we're talking about 8. Now this 8 can be written as follows, that is 7 plus 1. If we take the LCM of this, then the maximum possible value is 7. Again, this can be written as 6, 2, or 2 you can be written as 1, 1. So 6, 1, 1, that is the LCM will be 6. Again, you can write it down as 5 and 3. Now the LCM of 5 and 3 is 15. And if you go on like this, decompose the values of 8, right? So you will end up with values, the maximum value which will be 15, because any other combination which adds up to 8 will give you a number which is less than 15, like 7, 6 and so on. So the maximum possible the next question here is given that A is a 3 cross 3 non-singular matrix and AB is equals to 0. Then maximum rank of B is how much, right? So let us first see if we draw a 3 cross 3 matrix. So A will be A will have 3 columns and 3 rows. And now since this is a non-singular matrix, so of course the determinant of A is not equals to 0. Now for a determinant here, that is 3 cross 3, to be 0, not equals to 0, the value of which, then obviously for in every row we can have a number, because if any single row or single column is all 0 elements in there, then obviously the determinant will be 0. So in order for the determinant to be not equal to 0, then we should have any number other than 0 in every column and row. So that is why if we try to find out the rank of the matrix, then the maximum possible rank of the matrix A will of course be 3. So that now here is another condition given, that is AB 0. So rank of AB is equals to 0. Now so we have to find out the rank of B. That is, so we can, what can we write down is this AB, right? Rank of AB, which is 0. This should be rank A minus rank B, the mod value. Let us take the mod value of this. So the difference between these two ranks should be here, and the addition of these two ranks should be here. Okay, now this is the condition that stands. So here this is 0. Now we know that we have taken the maximum possible rank of A is 3. So that is 3 minus rank of B less than rank of AB less than rank of BA plus rank of B. Now if we take the rank of B to be 1, then how much do we get? 3 minus 1 less than, this is 0. Now this is 2 less than 0. This is not possible. So of course here again if I take 2, then 3 minus 2 less than 0, which will yield 1 less than 0, not possible. Then the maximum possible rank here for B should be what? 3, because 3 minus 3 is, then it will be equal to 0, right? So then it will be a possibility. So from this relation I can say that the for B matrix, given these two conditions, the maximum rank of B should be 3. we have our next question here. So we have to find out the number of isomorphism. So let us write down that U8, this can be written as this. So this is basically equal to this. So that is our Z2 cross Z2, right? So now here for this can be written as, so this is basically written as K4. So K4 to K4, that is 1 to 1 for homomorphism, right? Now the kernel of phi is equals to only the identity. For 1 to 1 we have only identity. Now here this K4, basically there are how many subgroups possible? So we can have identity Z2 and K4 itself, right? Now here we are not going to consider this because we need 1 to 1, so only the identity will be considered, that is K4 by this, which is equivalent to your K4. Now this falls in this, that is subgroup of this, so this is less than this, right? Now we have to calculate as per the question. So here we can write that the order of automorphism here is basically your K4 into 1. Now this order is basically S3 into 1, and order of S3 is 3 factorial into 1. So this is 3 into 2 into 1. So the answer is 6. That is the number of isomorphism here from U8 to U8 is 6.